Hello everybody, it's Mrs. Krantz, Algebra 2 class. You know these two, Leo and Zoe. They're actually on break today. Sometimes they get camera shy, so they wanted me to show you their mug, Leo and Zoe mug. Then a very, very special other mug is my kitty mug. Kitty was my very first TV. Look how cute. Chewbacca. Anyways, Lisa Krantz, Algebra 2. Hope you guys are doing well. We are going to go on today. It's Monday, April 27th, Algebra 2, and we are in Chapter 8, Rationals. And today we're actually going to solve some rational equations. Okay, we've been adding, we've been subtracting, multiplying, dividing, simplifying complex fractions. Today we're actually going to solve equations with an equal sign, all right? Figure out what x equals. Now, why is this equation called a rational equation? Well, rational means fraction, and specifically the x will be in the denominator of either one or more than one fraction, okay? Now these first two that we're going to solve, and again, if you need to, you can stop the video, write down problem 1, write down problem 2 if you want, all right? But these first two, we've definitely solved this type of equation before, okay? All we have is one fraction equaling another fraction, all right? One fraction equaling another fraction, all right? The way we're going to solve these, and I call these type 1 of rationals, is a simple little technique called cross multiply, okay? Because it's just when one fraction equals another, all right? And we've done this. So we're going to multiply -4 times x plus 2. Now we have to distribute that -4 in a second. Okay? Then we're going to multiply 3 times 5. So that equals 15 times x plus 2. So I'm going to distribute, and I'm going to distribute. I get -4x minus 8 equals 15x plus 30. Now, here's what will happen. This rational equation will become one of two different types of equations, okay? This is just a plain old linear. All right, now that we've gotten rid of the fractions, we solve a basic linear equation. All right, we're going to get x on one side. I'm going to add 4x. And then what? I think I heard someone say minus 30. Very good. -38 equals how many x's? Looks like 19. Divide by 19. You get a nice integer, -2. All right. So linears will have one answer. Okay. Now, we are going to check all of these, but you don't even have to check it by plugging in. You could. All right. But something's going to happen when we plug in x on this one. Right? What I just do is check versus what are the restrictions on x? What can x not equal? Well, when you look at the denominator, x plus 2 is not allowed to equal 0, right? We can't divide by 0. So subtract 2, x is not allowed to equal -2. And then same here, right? So -2 is the restriction, but we got -2. Ooh, so if you get a number that's a restriction, that's called an extraneous solution. All right. So typically, extraneous solutions will end up on another type of equation, which is the quadratic, which typically quadratics have two different answers. All right, and one of them can be extraneous and the other one's usually pretty good. All right. But here, there's only one and it's extraneous, so this is an actual no solution. Okay, not typical. Usually you'll get at least one good answer. Right? But on the first one, no solution. All right, now let's try the next one. We're going to cross multiply. All right, distribute. So I'm going to distribute 2 to x squared minus 2, and then -2 to x minus 4. All right. So we get 2x squared minus 4, and then -2x plus 8. All right. Now, this is not linear. This is quadratic, x squared. All right. So quadratics, you want to set equal to 0. So I'm going to add 2x and subtract 8, so negative 12. All right. How do you solve quadratics? Set it equal to 0. Then we're going to factor this. Now, to make the factoring a little easier, I'm going to divide every term by 2. I think that's on both sides. That'll make it a little faster. So x squared plus x minus 6. And then you factor negative 6 into 3 and 2. Which one's negative? I want to add up to positive 1. So the 2's negative. So x plus 3, x minus 2. Each factor gives you an answer. First one's negative 3. Next one is positive 2. 2 solutions. Now, are either extraneous? Well, all I need to do really is check versus the restrictions. All right? From x minus 4, x is not allowed to be 4, because 4 minus 4 is 0. Now this quadratic actually has 2 zeros. If I set x squared minus 2 not equal to 0, I add 2, and then opposite of squaring is square root. So it cannot be positive or negative square root of 2. Well, I didn't get square root of 2, negative square root of 2, or 4, so they're both good. Okay. These are restrictions. We didn't get them. Typical. Or if you have a restriction, typically one will be extraneous, the other one will be good. Okay. All right. Next one. Now, 3 and 4 are different than 1 and 2. There, and the rest of the ones we're going to do are type 2. They're type 2 because you have either a minus or a plus on one or both sides. Okay. So if you have a minus or a plus in your equation, you need to get first, I heard it. Grace, did you say it? Who said it? Was that you, James? LCD. I need a least common denominator. Okay. So the least common denominator of all 3 fractions, I need 3, and then I need x squared. My LCD is 3x squared. All right. Now, here's what we do with the LCD. It's similar to complex fractions. All right, so it's like what we do with the complex fractions. What did we do with the complex fractions? Well, we distribute the entire LCD to each term on both sides of the equation. We distributed for complex fractions to each term in the numerator and the denominator. Now we're going to distribute the entire LCD to both sides of the equation. Every term. All right. So I'm going to write 3x squared. How many times? 1, 2, 3. 3 times, because there's 3 terms. All right. 3x squared. 3x squared, and 3x squared. And then if we do it right, this is why we're doing it, we will end up with no fractions in the equation. Okay, and we're going to solve either a linear or quadratic. All right, so watch what will happen. What cancels here? 3's and one of the x's. So I get 11x minus 3's cancel. 1 times x squared equals, what cancels on the other side? X squared. So negative 4 times 3, negative 12. All right. Then we have another quadratic like the last one. I set it equal to 0. So I personally am going to add x squared, subtract 11x. I like to keep the x squared positive. Then this factors into negative 12 and 1. So we get x minus 12, x plus 1, and we have how many solutions? Hopefully you're saying 2. What are our 2 solutions? Positive 12, negative 1. Now I'm going to circle them both, but I am going to check versus what? Restrictions, okay? And really, I could just look at the LCD, right? 3x squared is not allowed to equal 0. So I divide by 3, that's 0. I square root, that's 0. X can't be 0. Whoa, we didn't get 0, so we're good. Okay. Two good answers. Two good answers. No solution. All right. Number 4. First step, find the LCD. What is the LCD? I'll put this one in blue. 2, 3, and 6. Sometimes it's just the bigger number, and it is 6. And then you also need x. LCD 6x, right? All 4 fractions. You're finding the LCD of all 4 fractions, right? So now we're going to distribute the entire LCD to all 4 fractions, and we will get rid of all 4 fractions. Okay. Write the LCD on the top in the numerator, and x's cancel. I get 30 divided by 2, I've got 15. Minus 12 divided by 3, I get 4x equals. On the other side, x's cancel. 1 times 6, 6. Plus, what cancels last? 6 is 5 times x. 5. All right. Now, this is just a simple linear, right? I don't set it equal to 0. I'm going to get my x on one side. Maybe I'll put it on the right-hand side. Add 4x and minus 6. 9 equals 9x. X is 1. Okay. Now, is it extraneous? Probably not. Let's check. What is x not allowed to be? From 6x, again, just 0. Right? Because that would give me 0 in these two denominators. So it checks. All right. So you have 1 good answer, 2 good answers. Occasionally no solution. That's not going to happen very often. All right. Number 5. We're going to do 2 more. Okay. This one looks a little bit longer and has a plus. So I need an LCD. But also, I need to do some factoring in the denominator. Okay. So how do I factor 15 to add up to negative 8? That is negative 5 and negative 3. Okay. So I factored. I have x minus 5, x minus 3. Then I have x minus 5. Then I have this, 3 minus x. Is 3 minus x the same as x minus 3? Not quite. All right, but I want to make them the same, and I can by simply factoring out a negative 1. All right. And that'll make the negative x positive x, and the positive 3 negative 3. All right. Why did I do that? Well, I just want x minus 3 in my LCD. I don't want x minus 3 and 3 minus x. Okay. So now what is my LCD? Well, I need x minus 5, and I need x minus 3. Now, I could include negative 1 in my LCD, right? But here's what I do with that negative 1. To make the LCD as least as possible, you can simply give the negative up to the numerator. So I'm going to give the negative to the numerator, and then it's gone in the denominator. Okay. So 1, I made negative 1. If it was a 5, I'd make it a negative 5. If it was already negative, like say it was a negative 6, I'd make it a positive 6. So just go opposite in the numerator. Right. And now I have an LCD, x minus 5, x minus 3. Okay. And we're going to do the distributing the entire LCD to all 1, 2, 3 fractions. So I'm going to write x minus 5, x minus 3. And then I write x minus 5 and x minus 3. Now watch the order I'm writing this in though. Okay, here it doesn't matter, they both cancel. Okay? And you get 7x plus 3 plus. Why did I write the x minus 5 second? Well, because that's going to cancel. And then I'm going to bring down plus 3x times x minus 3. And what's left here? So I got rid of the fraction, got rid of the fraction, and now which one will I write first? Well, I'm going to write the x minus 5 here, then the x minus 3. All right, what cancels here? X minus 3. And now I have this negative 1 that I have to distribute to the x minus 1. Okay. So remember what we're doing with solving an equation. You need an LCD if there's a plus or a minus. Okay. Then you distribute the entire LCD to each term on both sides. Okay. So I distribute 1, 2, 3 times. And then there should be no fractions left in your equation to solve. Okay, so what do I do? Well, looks like you have to distribute 9x squared minus, 3x squared minus 9x. Then here I distribute my negative 1, so negative x, double negative, plus 5. Now what? Ooh, this is quadratic. So I'm going to set it equal to 0. All right. First, let me get this side looking good. 3x squared minus 2x plus 3. All right. Now what? Add x minus 5. Add x, subtract 5. Got to set it equal to 0. So 3x squared minus x minus 2 equals 0. All right, now if we did it right, these should all work out in factor. Okay. So how do I factor 3? Well, that's 3 and 1. 2 is 2 and 1, but it's negative, and I want negative 1. So I have to actually make my 1 negative, that's negative 3, and positive 2 adds up to negative 1. So I've got 3x going with plus 2. All right, and x minus 1. So I subtract 2 divided by 3, x equals negative 2/3. Add 1, positive 1. Okay. Now, when I said no fractions, I just meant the equation was not going to have fractions. You can get a fraction answer. That's no problem. Okay. Now let's check. Versus restrictions. What can x not equal? Really, you just look at the LCD, find these zeros. X can't be 5 and 3. No, we didn't get 5 or 3, so we're good. Okay, last one. Do I need an LCD? Yes, I have a subtraction. Okay. So what will my LCD be? Well, let's see. I have x plus 6, I have 6 minus x, and I have x squared minus 6. This guy I have to factor. Difference of perfect squares, square root. You get x minus 6 and x plus 6. And then here I have x plus 6. And then here I have x minus 6, 6 minus x. Was similar to this 3 minus x, x minus 3. I want to make this 6 minus x into x minus 6 by factoring out a negative 1. That makes the x positive and the 6 negative. Now, I'll have an LCD x plus 6, x minus 6. And I don't want to include that negative 1. I'm going to give that negative up to the numerator of Tom. And this is now, it was a negative 5. It'll now become a positive 5 when I put it up there. All right, and now it's gone from the denominator. Okay. All right, so now what? Distribute the entire LCD to 1, 2, 3 terms on both sides of the equation. Maybe I'll put this one in green. Okay, so I got my red. So I'm gonna write x what first? I'll put -6 first, because the +6's will cancel. And I'll get 3 and x minus 6. Okay. Then remember, we change this to a plus and a 5. Okay. Then I'm going to write x plus 6 first, then the x minus 6, because the x minus 6's cancel. Alright, so 5 will get x plus 6, and that equals. Here I write x minus 6, x plus 6, doesn't matter what order, because they will both cancel, and I just get -12. All right, I know it's a lot of writing, but this canceling, all right, is an important part. All right, so now we get an equation, no fractions. We're going to solve it. Looks like it's going to be linear. We do not get any x squared, so we get to distribute. Then what? What do you think? Combine your like terms. How many x's? We got 8x. Then we've got plus 12 equals -12. Subtract 12. 8x is -24. Divide. What's x? Did I hear you say there, Lauren? Negative. You got it. 3. It's just a linear. All right. Is -3 extraneous? Well, what can x not be? Negative and +6. Checks. Okay. All right. So this is solving equations with rationals. A lot of times you need an LCD. If you're just cross multiplying, you do not need an LCD. All right. Chapter 8, we're at the end of the chapter, solving rationals. All right, I'll post an assignment, and good luck to you guys.